Asalamualaikum guys, welcome to episode 4 of my Python tutorial series. If you were with me in the last tutorial, you'll remember I was discussing about operators of the arithmetic and assignment type. There are two more categories of operators in Python, and today we'll be going over the comparison type. So here I have a reference table and comments on comparison operators, and from reading them, you may be familiar with some expressions, or known Pythonically as conditions. For example, we have the greater than or less than symbols, which you may have used in maths for comparing numbers. And this could be done the same way here in Python, where let's say I wanted to check if the number 5 is greater than 3, assigned within num1 and num2 here respectively, then I would simply use the greater than sign between the numbers, and when I print this out, we'll get a value true here in the console, which is of the Boolean type. So basically, whenever we use comparison operators, the result we get will always be a Boolean value of either true or false. Alright, let's assign this to a variable named comparison. Okay. So let's try the first operator here, the equals to symbol. If I apply double equals here between num1 and num2, and then print comparison out to the console, this will give us the output false. And that's because the operator checks if a value is exactly equal to another given value. From here we know of course that 5 is not equal to 3. And it's important to remember that in Python, this is what the double equal sign stands for, where the single equal sign is reserved only for assigning variables to values, as we did with the above variables here. Alright. To get a value true from this condition, we of course would have to make both numbers the same. So trying out num1 equals 5 and printing this gives us true here below. Or we could have also applied num1 equals num1, and that way we get the same thing. Awesome. And there's no problem with comparing numbers of different types. So if I compared num1, the integer 5, to the same number but of the float type 5.0, this will still give us true here. Basically every operator would not distinguish between floats and integers. Instead, both numeric types will just be seen as numbers. If I, however, compared their data types directly by applying the type function on both numbers, and by adjusting the print here a bit to see their types respectively, when I run this, we'll get the value false in the console, given that their data types, integer and float, aren't equal. Awesome. Now you could also apply comparison operators to strings. If I were to replace the numbers here with strings, say the first one be the word hello, and the word to compare it would be world. In the case of strings, the same thing applies as done with numbers, is that the equals to sign will check if both the words are the same, or Pythonically speaking, if both strings contain the exact same characters, in the exact same index order, and with the exact same number of characters. And we can already see that the two words are different, so when I print this out, we'll get a value false here as an output. If we wanted to get a value true from our comparison, we could then make the two strings the same. So let's replace world here with hello, and then printing this will give us the value true. Nice. By the way, if we wanted to compare a string and a number, we could also do that with these two operators. If I replace one string here with num1 and print this out, we'll get the value false, since of course the word hello is not equal to the integer 5. Moving to the next operator. This one's known as not equals to, which you could probably tell from the name that it functions like the equals to sign but in the opposite way. So let's replace the number 5 here with the string hey, and by applying not equals to here, would then imply that the word hello is not equal to hey, and printing this out would give us the value true here. Sweet. And this operator can of course be applied with numbers as well, so if I tried the not equals to comparison between our string and num1, we'd get true after printing this out, given that the expression correctly implies that hello is not equal to 5. Awesome. One thing to keep in mind is that the only comparison operators that can be used for comparing data types of completely different categories are the equals to and not equals to signs here. So for the rest of the operators, this wouldn't apply. So say I used the greater than sign here, which implies that our string hello is greater than the integer 5. Printing this out would give us a type error. So this would be a case of comparing apples and oranges really. Alright. Moving on to the next operator, the greater than sign. So with this operator, we've already tried an example with the numbers 5 and 3. Also having applied it just now with hello is greater than 5. So I guess you might already have a good idea about this operator. So on to the next one, known as the less than operator. This one works like the greater than sign, but in the opposite way. So when I apply this between num1 and num2 here, this expression then says 5 is less than 3, which of course is not true. By printing this out, we get the value false here. Alright. So these operators seem a bit straightforward, I guess, so far. Now we're on to the last two operators. These would work the same way as the greater than and less than operators respectively, except that they have an extra condition that checks if a data type is equal to another data type from the same category. So continuing with numbers here, but let's replace num2 with num1. This expression then implies that 5 is less than 5, and by printing this out, we get false. Since logically 5 cannot be less than 5, because that's weird. So to get an output true from this expression, we could just simply apply the equals to after the greater than sign here, and this would give us true after printing it out to the console. Basically, there are two conditions at play here. As long as one of them is true, then our result will be true as well. And in this case, 5 would neither be greater than or less than itself, but it at least passes the equality criteria among the two conditions. And therefore we get a final result as true. So even if I placed the greater than or equals to sign here between the numbers, by printing this out, we'll also get the same result of true. Awesome. Now you could also extend conditions by applying operators more than once to compare multiple values. Say I had an expression 1 is less than 2 is less than 3, where by printing this out, we'll get a value true here. So what's going on is that there are two operations applied here. One section is for checking if 1 is less than 2, and then the next one is for checking 2 is less than 3. Or we could look at the operations in any order. Basically, Python compares between two values for one operator, and then moves on to compare the next two values between another operator, and so on. And since all the subconditions here are true, our result for the full condition will be true as well. Sweet. Another example can be to check 1 is less than 2 is equals to 2, where by printing this out, we'll get a value true in the console. So the first operation deems true given 1 is less than 2. The next one checks out as well since 2 is equals to 2. Hence we get a final result true. Awesome. Now let's try a more complicated problem here. I'll just extend the problem with less than or equals to 3 here, then greater than 1.5, and greater than 5. You could extend your conditions even further with many values, and here's a complex one cooked up for you here. Let's try deciphering the condition. So the first section we've already checked, 1 is less than 2, we know as true. The next section, 2 equals 2, we also know is true. Then we'll check if 2 is less than or equals to 3, and we know that that's true. Then the next section would be to check 3 is greater than 1.5, which is also true. And for the last comparison, we have 1.5 is greater than 5, which is false. So now that we've found the false amongst our true values in the full condition, we'll get a final result as false. Printing this out, you'll see that the value false is here in the console. And this is an important note to keep in mind, is that no matter how many subconditions result to true, if we find even one condition as a false, our full condition would give the result of false as well. Alright. Now for the last part of this video, I'll be talking about comparisons between Boolean values with these operators. In Python, Boolean values can be identified by numbers, so for the value true, its numeric equivalent would be 1. And for false, it will be 0. We can prove this by using the equals to operator. So let's check if true is equals to 1. Applying this and printing it out, we get the answer true here in the console. Similarly, for checking if false is equals to 0, when this is applied and printed out, Python's happy here and says, yep, it's true. So we now know that Boolean values are really also known as the binary values of 0 and 1. These values can be applied similarly as numbers for comparing with other numbers. So say if I checked that false is less than 1 here, by printing this out, we'd get true here in the console. The expression here would be read exactly the same as false is less than true. So you can see that we get the same result true when printed out. Awesome. So let's try out another complex problem. I'll just type out a long condition. 1 is less than or equal to true, greater than false times true, less than true plus false, and greater than minus 1. Cool. Now let's try deciphering this. First we check 1 is less than or equal to true, which is true given that the equality condition applies here with 1 is equals to true. The next one's true is greater than false times true, so we have an arithmetic problem involved where false times true would give us 0, since we're just doing 0 times 1 here. Therefore we have the condition true is greater than 0, and that is true. Now the next one 0 is less than true, which is pretty simple, that's true. And then we have true plus false is greater than minus 1. So true plus false just means 1 plus 0. This condition now says 1 is greater than minus 1, which is true. And now we can see that all of our subconditions are true. Therefore, by printing this out, we have our final result as true. Fantastico. Alright, so I've discussed in length about comparison operators, and we've now reached the end of this tutorial. I hope this video was helpful for you in understanding conditions in Python, and you'll get to see how these conditions play a big part in many programming tasks. One good example can be for checking if a user's sign-in password is correct on a website or app by using the equals to sign in our code to do so. And many other great examples of using conditions. Cool. For the next tutorial, I'll be going over logical operators, the last category of operators in Python. So hoping to see you in the next one. If this video was useful, give it a like or subscribe, and stay tuned for the next video. Thank you very much for watching. Take care, and Asalamualaikum.